Hi, I'm Brittany. In today's lecture, we'll be discussing the rock cycle, the origin of rocks and the minerals within them, as well as the different types of rocks and their uniqueness. So let's get started. The origin of rocks have been heavily studied, with many geologists testing out this theory by studying the formation of whereabouts of rocks. To many scientists, this started with a big boom. Dun dun dun. This big boom came from a star explosion, in other words, a star death, aka a supernova. This event led to the star bombarding elements between 1 to 26, with the iron included, onto Earth's surface. As the elements sat on Earth's surface, the heavier elements moved onto closer to the core, with magnesium and iron being closer to the core. This led to the introduction of iron, or better known, or this whole process being well known as the iron catastrophe. So let's get started with compositions. The four different main types of rocks that we're going to be talking about, or the four total types of rocks, are ultramafic, mafic, intermediate, and felsic. They are ranged from densest to least dense, as well as the dark to a more lighter shade, with also one including a salt and pepper type of rock. You can see it more. Now, they come in different forms. As we separate each type of rock, we can separate each type of rock into three main type of categories: igneous, sedimentary, and metamorphic. Igneous rocks are mainly derived from magma and lava formation, with them having little to no layers, as well as having different types of cooling rates, with one cooling rate being called an intrusive type of rock. They have a more slower cooling rate, which allow for them to collect rocks along the way as they get cooled down. This can lead to more conglomerate type of rock. Now, an extrusive rock has a more rapid cooling rate. These rates keep their composition with no other rocks being present, which are all uniformed. Now, for sedimentary rocks, they come from compaction ranging from chemical weathering, clastic, or organic compaction. This could be from rocks being layered over on top of other rocks. This leads to a more brittle, layered type of formation within rocks, making them easier to break. Now, metamorphic rocks are the last on the list, with them forming by transformation of other rocks, showing layers within them, called foliation. Now, the first rock we want to speak about was the densest. They are high in iron and as well as magnesium. This type of rock is the oldest and richest in minerals. With this being said, we can tell that they derive from a deeper part of Earth, more specifically the mantle. Due to their composition, they're never seen on the Earth, as they require large amounts of heat and temperature to be inputted. Now, the second one, it's very similar to the ultramafic rocks, but at a more lower scale, disappearing in different shapes. A few minerals that can be composed of are pyroxene, bioclase, feldspar, and sometimes olivine. All right, and then the third one is called an intermediate rock. Now, this is a special rock due to its components. This rock would be considered the middle child, with it having some characteristics of felsic, mafic rocks. Due to this, they are better known as salt and pepper rocks. This type of rocks are high on silica, iron, as well as they coming in different type of shapes, with it having extrusive and intrusive types. Remember, this is cooling. Now, lastly on our list, we have felsic rocks. These are lighter in color, weight, and can be also found around the continental crust, as well as different types of mountain ranges. In the images to the right, you can see a more darker type of color. On this rock. Although the felsic rocks are usually lighter in color, due to some impurities that have gotten in the way, they can change the color. As you can tell, obsidian is more of a glacier color to it. Now, where can they be found? A few areas you can find these types of rocks are deep in the Earth's mantle, ultramafic, and you can see ultramafic and ophiolites. Now, for the mafic rocks, they can be found near hotspots where there are a lot of volcanoes, a lot of activity. Intermediate rocks can be near subductive zones and volcanic zones. Side note, when rocks are near subductive zone, the more denser they are, it can be hard for them to get onto the surface, making them go back into the Earth's mantle and going through that cycle again of melting, remelting, and so on. And how are they formed? Ultramafic rocks can be formed. Oh, matter of fact, all of the rocks can be formed by different types of temperature and pressure. This could be from them needing an abundance amount of heat and pressure, which can be found within the deep mantle for ultramafic, to having little to no temperature and pressure needed, and can be found around the continental crust for felsic. Now, what affects formation? A few things that can affect formation are pressure, temperature, presence of water, rock compositions, or the source that they are in. They can come from tectonic plates, or aka hotspots where there's a lot of activities as well. Now, the different types of minerals. Now that due to the different types of temperatures and pressures needed to form rocks, they can be reversibly melted at those temperatures. The greater we get into the mantle, the larger number of rocks we melt along the way, with it leaving the denser rocks to be partially melted. When they cool down, they can still attach to other minerals present, making them different in percentages of minerals present per rock. For example, a mafic rock can have an abundant amount of silica, but still retain its characteristics of mafic. We can use the Bowman reaction theory to this. As you can tell, the more down we get, the lower the temperature is, and the more igneous, more lighter rocks come to form. Now, lastly, to wrap things up, a rock cycle. It's a rock cycle, or in my way of saying it, a family tree, which is always constantly growing and changing. This could be through subductive zones, tectonic activities, and so on. But overall, rocks share similarities from their origins, from the origins, which is the iron catastrophe, to similarities in melting temperatures as well as minerals. Rocks are all the same, but in different ways. They are unique in their own way, as well as beautiful. You can see this by the presence of different types of little minerals within them. So their sister rocks, they can have little parts of their sister rocks within them. We can try to make it a little bit more of a family tree, but it's really nice and very beautiful. So you can go outside and find different types of rocks that are unique to themselves. Thank you so much for coming to my